It's me again, Professor Fleming here with Solar Power 4.3.3. This is the part of the fourth lecture in a series of 7 lectures on perspectives on environment and energy, and is part of the course Principles and Methodologies for Sustainable Design. In this section we're going to be looking at solar power, or as I like to see, energy from flows. So a couple things about solar panel in terms of the facts. We've got units in kilowatts, and we can also use megawatts there for really large systems. And of course the units of power are kilowatt hours, which is what shows up on our energy bill. Efficiency per panel is actually very low. We're only getting about 18% of the total sunlight energy available from each panel, so there's a lot of opportunity there. Profits are very low relative to the profits of fossil fuels, and the high cost to install is also a problem. But the externalities, the negative externalities, are actually very low, and the reserves can come from improvements in the technology as they continue to get better. So the other problem we have is large spaces needed to accommodate PV arrays. So in order to get a lot of electricity, you need a lot of space. So that's one of the problems. The other problem is we're not going to have 24-hour sunlight. Given all of that, and given all the limitations of solar, look at what's been happening in the world in terms of solar cell production. The red line there on the right going way up over the last few years is a really pretty remarkable explosion in solar technology. And that's driven in part, I would argue, from a new world view that's thinking more about integration and thinking about future generations, and also the price and cost of traditional energy sources like gas and oil are expensive enough where these technologies can now exist as substitutes or reserves for the fossil fuels that we've typically been using. So we can talk about this as a substitution for oil. As oil prices rise, PV becomes more attractive and becomes more viable economically as a technology, even with its lack of 24-hour access. The commercial applications of PV started in space, and so this goes back again to the abundance principle and the idea that humans are inherently curious and will continue to make improvements. The simplest photovoltaic systems are powering calculators and wristwatches. And now we've got, of course, more complicated systems that power buildings, etc. If you look down there on the dark blue line, the global module price index for solar keeps dropping from what it was in 1998, about $5 per watt installed. We're down to almost $1 to $2 per watt installed. So what we're seeing here is an increase in demand and a decrease in the cost of the actual technology, which actually creates an explosion. So some people would say right now we're in a second industrial revolution. I don't really want to think about it like that, because I think this is a very different kind of industrial revolution that we're in. But nonetheless, it is pretty amazing of what's going on. Some of the facts we don't care about. I'm just going to skip through those because we already did that. Solar power, from an experiential point of view, provides great comfort and convenience to millions of people again. Maybe not millions, but certainly thousands or maybe millions, depending on where we are. The problem is that it has a negative connotation visually, and many people object to the aesthetics of the solar panel on roofs, for example, and it's creating quite a barrier to the further widespread development of this technology. However, if you look around us at the physical environment, the built environment, we do see power poles for electricity conduction everywhere. And so, for example, this is quite a common view here, at least in America, and I've seen it in other countries, that the infrastructure is ugly already for electricity. So it surprises me that people then begin to rebel against photovoltaics. But remember, designers are very creative people, and so over time, PV panels and their systems will become more creative and more attractive. But nobody's clamoring to get these telephone poles down, at least places where there's not a lot of wealth. And so the negative connotations of solar will begin to go away as people see the inherent value to their daily functions. It's a pretty critical distinction there. Distributed systems are very useful as infrastructure because they are robust and, in a sense, redundant. And so what we see with PV is the opportunity to have off-grid buildings. What's blocking that right now is the introduction of battery technology that's cheap enough and powerful enough to store solar electricity in an efficient way. So in terms of the systems, we do want to get to a decentralized system. We'd like to have a closed loop system. When we introduce batteries to a closed loop system, it doesn't become closed anymore, because the getting rid of batteries and recycling them is almost impossible right now. Ecosystem impact's quite low, actually remarkably low compared to fossil fuels. However, the energy is not available on nighttime and not available on cloudy days. So we can't say that solar is the holy grail of energy, but certainly has offered us great value. So if we look at the steps here, I've messed with this a bit, because one of the things that I see here is step one, I have photovoltaic array converts solar energy to electricity. 2, we have the inverter, which is needed to go from DC power to AC power. 3, we have our breaker box where we get our interconnection with the grid. 4, we have a meter reading and the energy goes out to, and 5, out to the distribution to the utility. So we call this net metering, where when we have solar panels, that energy is fed back into the grid and you get a credit from that from the electric companies. So eventually, even though you have solar panels on your roof, for example, you don't actually use any of that electricity directly. And that's something that we're looking at overcoming in sustainable design, but we have a little ways to go. So we covered that already. So thinking about incentives, looking at solar and how it might, this is looking at culture and society. So worldview integral, societal benefits, tremendous benefits, because it gives us energy now and it protects people in the future, both environmentally, and builds the framework of a new energy grid for future generations. Some of the concerns that have been raised are dangers to firemen who get shocked when fighting fires. So depending on the country, and you'll see the building codes now and the electricity codes are requiring very clearly marked shutoffs on the sides of buildings before firemen even start fighting the fire. They can shut off the PV array, which actually has caused some explosions and some deaths among firemen. We're talking about deaths under 100 people as compared to fossil fuels, for example, where the deaths are in the thousands, if not hundreds of thousands, if you include climate change. So this was another slide on that. So now we're going to talk about solar power, some examples. I said before, the idea of making solar power beautiful is really critical, and on the right you see the solar shades that have been developed, and that solar array right there is charging those vehicles. And that's really something you're going to be seeing quite soon, is not only will you see electric vehicles, but they will be powered by solar, because remember, those vehicles have a battery in them already. So that capacity can be used by solar directly. On the left you see in Europe the beginning of gigantic solar installations along roads, and this makes a lot of sense because you have a lot of open space and access to the sun, and these solar arrays are becoming, again, more efficient. And also keep in mind that the buildings themselves and the appliances inside those buildings are also becoming more efficient. I'll explain more about that as we get towards our conclusions. We also have something called Building Integrated Photovoltaics, which are BIPVs. Here the photovoltaics actually replace the construction material. So instead of installing a window and then a PV panel on top of that window, the window is the PV panel. And this is a trend that we're beginning to see in architecture, where if I'm going to be installing a roof, for example, why not have that roof already have the solar technology integrated into it? And here's one of the first examples in England. This project was clad in PV and started feeding electricity to the national grid in 2005. So all of a sudden the buildings now are, or not now, but will be in the future, actually exporting energy directly to the grid. It's pretty exciting, and we're really at the beginning of the revolution of solar energy design, and that has a lot to do with the price of oil and gas. That being really expensive makes all of these technologies more viable. In the US and now in Europe, we have something called the Solar Decathlon, where different universities take on the challenge of designing a net zero energy house. They build them in their universities, and then they transport them over to the National Mall in Washington, D.C., and I believe there's one happening in Europe this year. And here's where a lot of the newer, more emerging solar technologies are tested out and put to work to see if they can actually be effective. And this has been wildly popular in the U.S. with millions, literally millions of people visiting these homes every 2 years when they're built. I think the one in the U.S. is going to be in California this year. Pretty exciting, actually. And again, large-scale solar installations, bridges, have excellent access to daylight and sunlight. So this is actually in London, where they actually covered an entire bridge in solar. And these are done by the government, so this energy goes back into the grid and is used to power government facilities. Again, pretty exciting opportunity here for the future of solar. So let's do a summation here. From an experiential point of view, facts: culture, and systems, we're going to look at solar. We have to acknowledge the fact, like we have done with all of these energy sources, is they create comfort and convenience for millions of people. The role that comfort and convenience plays in human evolution cannot be underestimated. We've talked about it already. I'm just going to kind of move on. But we do have to overcome the visual barrier of solar panels in society, either through education of people in the world to be more accepting of solar visually, or designers have to do a much better job of understanding how to make solar panels more beautiful and how to better integrate them into architecture. It's a big challenge in sustainable design and something we spend a lot of time in our program as we do a lot of net zero and carbon neutral projects here at the university. Units can be kilowatts or megawatts if you have a big system, and again, kilowatt hours or megawatt hours can be some of the units. Profits relative to fossil fuels quite low, but rising. However, the externalities are very low in terms of the negative externalities. And I did some research into the harvesting and mining of silicon, which is a critical material used for solar panels, and the environmental impacts right now at least are pretty low, and the human impacts are actually pretty low. And the reserves, of course, come from the fact that the panels right now are only 18% efficient, meaning that we could, through technology, make each panel 5 times more effective in its performance. From a culture and society point of view, we're looking at a state-of-the-art energy system that fits in with our emerging worldview of sustainability and integration. The societal benefits, of course, are high. The societal costs are very low. Some firemen have been killed, and now shut-off switches are installed. However, solar is very expensive, so these technologies are not available to the average person. And so the cost has to continue to come down to make this something that's viable for all people in society who should have the right to have access to these technologies. And solar arrays and solar panels are decentralized energy, although right now we still have to connect back to the grid. The ultimate goal in sustainability is to create redundant and robust systems like you find in ecology, so that when shocks occur to the system, we can continue to function. Relatively low infrastructure and decentralized infrastructure compared to what we see for fossil fuels, but the national electricity grids in many countries are out of date and really aren't set up to handle an influx of energy that's not consistent. So we'd say that solar panels are almost a closed loop system. The research shows that you have to use solar panels for 2 years in order to recover the embodied energy impacts from the making of those solar panels. So there really is probably nothing other than what's in nature as a completely closed loop system. Ecosystem impacts pretty minimal and very poor 24/7 availability. So we get into the same situation where solar plants have to be or can be connected to natural gas electricity producing plants, or at least paired with in theory, to create a continuous flow of energy into the grid. So not completely perfect. Is this a sustainable energy choice that should have a question mark? I'd say relatively speaking, yes, compared to what we've seen throughout the lectures that we've had. As battery technology will soon allow our buildings to operate completely off-grid, that brings a whole nother level of resilience and higher performance available. And we have to find a way to make solar architecture and interiors and landscapes more beautiful and more functional, so they're more widely accepted. Although I think generally the culture is moving towards acceptance of these. Pretty exciting really when you think about it. Okay, thank you.